You're making a video. Unfortunately, the free will thing I was doing it's kind of gone sour. Because of this, whatever, this MP3 thing. Anyway, this conversation between George and the other guy, Chandler, and Sunday is when we had a group meeting, and they were all for making another program about doing this deeper philosophy stuff, and I voted against it and just said, no, let's not do that because I'm just gonna. This is just going to get into some thing where I'm going to have to point out you're idiots and imbeciles, and that's not going to be any good for the show, and it'll all make you look incredible and stupid, and So anyway, I gave them every indication that's not something I'm going to do, and anyway, so they decided to do it anyway. So what can I say? It's I'm not going to do that. So anyway, I'm not going to, I'm not going to lend my support to spreading ideas and speculation and just made up shit. People having conversations. I mean, I called it, what, you want to just rename the show to the Phantasmagorical Hour? It's just no point. Well, anyway. So, I mean, there's no hard feelings, I would imagine. It's all, I don't have the free will to do otherwise than to say, I ain't doing that. I ain't selling that shit on the internet. It's, toxic waste and shit. I ain't dumping that in the drinking water. So I just thought I'd play this just to point out why I find it so obnoxious. And it really, it's all the way through. It's just such crap. So anyway. So I figured I'd just make a response video. But this also kind of indicate that, it's so easy for people to say stupid things. And then you have to, the explanation of how you've got it wrong. Because they have this simple, stupid, ignorant statement. And then you have this, there's a whole complex explanation for why it doesn't work that way. And I've been griping about words like random and spontaneous, in our vocabulary, and how they're just really dangerous words, and we really got to find some way to talk around them. It's even like talking about ourselves, and talking when we say I thought of, or I thought, or I, just this idea that, I think we really do have to try to say something like my brain, and just try to disconnect from this language that keeps reinforcing ideas that are just wrong. And, so they did a lot of that in here. So I just thought that, this is going to need some contextual description. The explanation of why it's wrong just requires a little bit of education. So I have to make an educational video. So I figure that's what I'll do. So this might take a couple of parts. So we'll just do it. We'll just see how it goes. We'll just play with it, and I'll just play with, maybe I'll just pick on every single bit just to explain, just to explain context.
Hi, welcome to Free Will, Science, and Religion. My name is George Ortega. I'm here with Chandler Klebs, and today we're talking about something really, really interesting. Basically, many of our podcasts have to do with explaining why free will is impossible, why we human beings do not have a free will.
Right, you should have just stayed on that subject. So, I didn't have anything to do with the naming of it, the Free Will, Science, and Religion podcast. I didn't see any real problem, including concepts like science being the source of understanding, and religion being something to just talk about as a sickness, as a brain psychosis, delusionary brain psychosis.
However, along with that understanding comes the question, well, if our wills are not up to us, if our thoughts, feelings, actions are not up to us, who or what do we ascribe them to?
Right. And this is where, they're going to say it's the universe is creating them. And it's literally true, right? I mean, the universe we're a byproduct of the function of the universe. But we're a byproduct in the complete sense of that word also. It's just a function that's possible in the mixing of these mechanical parts. And so you have to kind of go back to the fact that most of the universe is doing this incredibly simple thing. Most of the universe is in an elemental form. That means it hasn't even made molecules. It's just made atoms. It hasn't made combination molecules. And most of the universe is hydrogen and helium. Um, and then there's parts of it that have condensated into these other elements through the process of the mostly early universe that made the heavy elements and the incredibly hot universe, the supernova of a sun. And these other elements are created that have some properties that are different. So we know that the different elements have different properties. And that's what most of the universe, the form it's in. And then in some quieter places of the universe, those elemental pieces can mix. And like they land here on Earth, let's say the Earth has gold on it, or in it. And where did the gold come from? Well, it came as individual atoms, from different circumstances happening in different places in the universe. And it landed on Earth, and was when the Earth was in a liquid form, a molten form. And through the process of this chemistry, the gold atoms like each other, so they stuck to each other. They like each other more than they like the carbon atoms or any of the other atoms that were available to cling to. And so the gold atoms ended up being filtered into little pieces, little strands of gold, little clumps of gold. And so we think of that gold as being something fundamental, but it's not really, because it was made of all these little constituent parts. There's all different, each gold atom has a history of its own. So that's a context. Now there's a whole bunch of context you can give to this, what is the universe doing? Well, the universe is making chemistry, okay, but it's not making it like, I think gold would be a super idea. And then it says, let's mix two metals together and come up with things like nickel, and let's put oxygen and oxides, and let's have all oxides and carbon monoxide, and let's have all kinds of combination of chemistry. But that's all that's taking place, and it's only taking place in a small part of the universe, density-wise. Most of the mass of the universe isn't doing that. So anyway, continuing.
Okay, so Chandler, start us off. How should we theorize? What should we ascribe our thoughts, our intelligence, our actions to?
Well, here's how I would put it. I would say that our intelligence as well as our consciousness is not something that all of a sudden magically appears once you have a fully developed brain and nervous system.
Yeah, no, right there, that's just such huge trouble, right? You don't need a fully developed brain and nervous system to be conscious. All you have to do is hit me with a pretty small rock, and I'm unconscious. It just takes a tiny defect in the function of my brain, and I'm no longer conscious. And yet he thinks that consciousness isn't something that needs a working brain to manifest. And of course, it does require a working brain, and it is all a brain phenomenon. It doesn't come from anywhere else. You have to have a brain to be conscious. A brain can be in any form. I'm not saying it has to be this exact biology, but it has to be this exact. That's a little bit annoying. But yeah, there's a lot of things that are a little bit annoying. Yeah. If I'm one of the hundreds of millions of Americans suffering from chronic back pain, I should listen to some dopey recording, because that'll make it all okay. Yeah, right, the universe is doing that. Yeah, it's one of the universe's ideas. Spam telephone calls. Yeah, so it's a brain, okay, and the brain is a reflexive. This is important words, right? We have words that don't mean anything, like random and spontaneous, but the word reflexive, that's a big one. And that's really all this is about, is that what's the concept of a reflex? Is kind of a way of storing a reaction, moving an action from, the action takes place at point A, the reaction takes place at point B. And in a way, obviously, if you could make that chain circular. You could have an action at point A, and then you can have the reaction at point A, and that kind of thing. But reflex is where it all starts. It's a mechanical process. It's a trigger. It's a lever. It's a mechanism, and that's all the brain is made out of. It's a bunch of this mechanism, but it's a bunch, 100 billion neurons, and it has synthesized a concept of value, which is fundamentally important when it comes to programming. You can't have a computer do analysis unless we program it with a value system. Well, our biology had to create that programming without having a program. It had to make the program. It had to make the mechanism that would judge the authenticity or the usefulness of changes that were taking place in the biology. And the only way the way it came up with synthesizing that was, ironically, to create something of real value, which is this illusion of sensation. And it is an illusion. It's an important word too, that you can just talk forever on this concept of what that means, but it doesn't mean it doesn't exist. It just means that it doesn't exist as a material creation. It is in of itself exists as this relationship of my brain that has confused or diluted or made an impression inside this mechanism that I'm participating, that I'm active, and that I have these sensations. But it's just software. It's one hell of an illusion, as Einstein would say, but it's an illusion nonetheless. But anyway, you can go on. Again, this is a subject somebody could go on forever, but there's nothing in our mechanics that's somehow outside of this idea of 4 billion years of tool building. And so I guess that's the concept I'll just emphasize for this video, as a concept I've talked about often, is that we're just a collection of tools. And the way evolution works is that it makes a whole bunch of organisms, and they're all subtly and slightly different based on mutations. And the ones that have tools through that mutation process that work better, that get them more food and in turn make them more capable of reproducing, are the ones that are likely to survive the contest. And that genetic code will go into the future. But it's the genetic code that evolves, and it evolves based on creating a bunch. We're how the genetic code communicates with the world. We're the demonstration model, and what happens to the demo, it's like a pilot program in television or something. We're the experiment, and if the experiment doesn't sell, then the other experiment wins. That's just the way it works. There's no mystery to it. There's no, and it's not a complex game we're playing. We're playing a really simple mechanical game, and the tools are sophisticated and complex, but they're built incrementally, one little switch at a time. Anyway, continuing. Sorry, my lips is all dry.
Because I don't think it's something that evolved, but rather something that had to always be there. And the reason I say this is because...
Had to always be there? I mean, it doesn't even make any sense. I mean, it didn't evolve. What do you mean? So we weren't apes. The apes weren't dogs. The dogs weren't salamanders. The salamanders weren't fish. I mean, you're denying evolution then?
How do you get even the idea of consciousness from living cells if those living cells aren't already conscious?
Well, there's the old God crap again, right? I mean, your answer doesn't answer the question. Then you'd have to answer, well, how did the cells get consciousness? well, they got it from the elements, and well, how did the elements get consciousness? Well, they got it from the atoms, and well, how did the atoms get consciousness? Well, they got it from the electrons, and how did the electrons get consciousness? Well, they got it from the photons, and so now we're back to photons. So photons have all the brains, right? And we're just the stupid byproduct of the smart photons. No, it just doesn't answer the question, okay? This brain is a tool. It allows this organism to see. It allows it to sense the environment and react much more sophisticatedly than many other organisms, especially organisms that don't have the capacity to learn. I can learn as I'm living. My programming can be rewritten. Where many animals, they're just born with some programming. Like a gazelle is born with the ability to run and to move its legs appropriately. It doesn't really learn it. It's a program that's already built in because it has to have it immediately. It has to be able to survive right away. Where humans had the luxury of being essentially brain dead, to be born prematurely and to have the substance of their orientation to reality happen through the first couple of years of their maturation, where basically the machine doesn't have to work, it just sits back and learns. Anyway.
And how do you get any idea of intelligence or know-how to be able to respond to your environment unless the cells already know how to respond to that environment? And when you have an
I mean, that doesn't even make any sense, right? I mean, my cells in my brain have no idea what I'm doing. It's like when an ant builds a bridge across a stream. It doesn't know it's building a bridge across the stream so the other ants can get across. It has no idea that's what it's doing. It has an instinct. When salmon swim upstream, they're not thinking, I'm going to spawn and create the next generation, and it's all going to be great, and I'm doing a great thing. No, they have an impulse that drives them upstream. They have no idea why they're doing it. They're doing it because they're hungry and they're following their hunger. Oy.
your blood cells, the skin cells, it all just heals it up, unless it's too major, and you heal, and you don't have to consciously in your brain.
Right, and you can find plants. You can cut the plant in half and stick the two pieces in dirt, and they'll grow new roots and be another plant. And yes, that's the biological mechanism. I cut my finger off. My finger will cellularly. It'll do things that will preserve it. Okay, it won't just the blood vessels will close. Certain things will happen, and they'll happen because there's a reflex built into us at all kinds of levels. There's chemical and even some electrical reflexes that work whether we're paying attention or not. I can take most insects, I can pull their brain off, I can pull their head off, and their body will still walk, it'll still move a lot, it'll still do a lot of stuff because a lot of its autonomic nervous system needs to be so, it has to be so quick. The world they're living in is moving so fast that that there's real advantage in keeping that stuff right at the source. So when a caterpillar is moving its legs, its brain isn't moving the legs. It just says, this is the move program, move. And it tells the secondary node brains at the reflexive points to do the job. But that's where the programming is. So it's again, I would argue, because humans didn't have the demand of the kind of quickness, maybe if we were flying organisms or something, or we're doing something that required a real physical acuity, that maybe we'd have some of these reflexes tied to those kinds of things, and our brain would be spread out a little bit further just to make our response time quicker. But we don't have to respond that quickly, so we can afford to keep all the output control mechanisms fundamentally in our brain. But obviously things like the skin healing, these are just chemical reactions that have been built into the system over 4 billion years of evolution. And you could say 500 million years since organisms had beating hearts and circulatory systems and all this stuff. So it's a highly developed system that has gone through. I mean, I can't even give you a number of how many models have been built. Just the number of species alone is a preposterously huge number. But the number of individual trials of this biological living mechanism, the actual number of things that have lived, is preposterously huge number. I mean, it's a 10 to the 500th power. I mean, it's a gigantic freaking number. So yeah, it works because it's been tried. It's been tested hard.
Start that process. It's already done by your cells. And so I think that life is much more beautiful, mysterious, and amazing than people seem to believe.
Oh, it's such
All right,
subjective mush. I mean, beautiful is just subjective crap. I don't know, whatever the other mysterious and fascinating and wonderful, whatever his idiotic language was. Just subjective mush, so there's not much you can say about that. And it just doesn't appreciate the point that the rules guiding, the rules confining this process of complexification are rules that have no compassion, no understanding of what it is to suffer, no nothing. There is no built-in knowledge of any of the things we would call values. There's not even any built-in knowledge of what you're calling beautiful or aesthetic. It's the basic function is success in the genetic realm. And for things like the weather, right, there's just simple rules of hydrodynamics and currents created by the movement of temperature gradients. There's no intrinsic necessity to say somehow the water droplets know they want to be a cloud and then they want to help the cloud heal. No. That's silly.
I agree with you. I think there has to be kind of like some kind of fundamental consciousness, intelligence. But let's just
Fundamental consciousness and intelligence. So not only is it conscious, it's intelligent. So I mean, obviously they don't know it. They don't have any reasonable definition of these words. They're fundamental words to understanding the concept of free will or your will, whether you're acting on an intelligent will or a desire will. It's a fundamental concept in understanding that. So if you don't have sensible, reasonable, confined definitions of these words, there's no point in having a conversation about free will, I don't think. Consciousness is a fundamental property, and I think it can be conclusively stated that it's a property of neurology. If I cut my finger off, my finger is not conscious. The cells inside my finger are not conscious. They are not conscious entities. They are not experiencing their lives. There would be no point in it. They can't run away. They don't have legs. They don't decide to move in another direction because of anything other than chemistry. Cells do not move by volition. They move by flow of circumstance, by chemical causes. They're all just chemical reactions. Do you understand the words chemical reaction? This is something you learn in grammar school, this concept of chemical reaction. Chemicals react to each other. They repel, they combine, they do a lot of interesting different things depending on the circumstance, but they react in a very ignorant way, not a very smart way. You don't call fire intelligent. It would be stupid to call it intelligent. and it would certainly be ludicrous to call it conscious.
Describe in a bit more detail how we get there, how we get to this conclusion, this understanding. Okay, we start off with the recognition that what we do, what other organisms do, what other animals do, etc., is not freely willed. You know, it's not up to us. And one way we can describe what.
See, another thing that's really important in these conversations that nobody really gets, I've talked about before too, is we have this stupid word life. And we talk about living things, and then we talk about animals, and we talk about these things as if we haven't made distinctions between what they are. We are as different. We're fundamentally different from parameciums or microbes. We're the most outstanding feature of us is our neurology. We're not the most insignificant part of us is the biology, the mechanism that keeps us alive. It's a minor feature of our existence. Yes, a necessary one, but it's a minor feature compared to this capacity to sense the environment and to process it with this complex 100 billion strong neural network. And so it's almost silly to call us the same thing, to say your life, to pigeonhole these different organisms into this sameness, because the only thing they have in common is the fact that they are built based on DNA replication. They have one thing in common that doesn't have much to do with the properties they have acquired. The properties of a multicellular organism. I mean, I'm made out of cells. My neurons are cells. I'm made out of what this other stuff you're calling life is. So you can see the problem. If you're calling the thing its tissue, you can't turn a tiger into muscle. A tiger isn't muscle. You wouldn't call it's a muscle. It's just not an adequate, or it's fur. It's much more than the biological process. The fact that it has a genetic origin, that it's part of evolution, it just doesn't make much sense to call them both the same thing in almost any conversation. It's the most the thing we have in common, the things I have in common with a paramecium are the things most irrelevant to what is at all interesting about being human. So, we need another word for sentient life, conscious life, versus unconscious living things. Biology animated. That's biology just animated. It's a machine. A microbe is a machine. A cell is a machine in every sense of the word, where obviously we have this illusion thing happening that makes us a different classification of machine.
Actually controls our actions and thoughts is mechanistically through this law of cause and effect, that essentially our thoughts, our actions are the direct causal result of, let's say, most generally, the state of the universe at the prior moment, prior to whatever is done, whatever we do. And then
So where he's going with this, right, this is accurate, okay, that it's all cause and effect. But where he's going with this is that if you take these causes and effects all the way back, that there was somehow knowledge at the instant of creation that this creation will include human beings and it'll be really cool, we're going to make humans, when that's not the probabilistic understanding. You could understand that, yes, all the complexity that exists now was built into that moment of creation, so to speak, the moment the ball started rolling after the Big Bang, let's say. That all these motions were already preordained, They have to be played out, though. They have to absorb time and distance to be able to be played. Well, distance and time is the more right way to say it. Um, Before they can be realized as this permutation. But the fact that it came out this way would be fundamentally and radically changed just by the migration of one tiny particulate of it. Moving one grain of sand would change the entire face of what was created. And what has to be understood is that if you understand something about biology, you'll understand that you could just take life 500 million years ago, and the odds are, the reasonably deducible odds are, that if you were to put it in that state and create variety, you would have to do it for perhaps billions of years before you would ever create a neuron again. That the creation of a neuron was almost one of these bizarre events, not common events. So if you're rolling Yahtzee dice, and you get 5 fives, the obligation to get a neuron is that the 5 fives have to be stacked on top of each other. So it's not going to happen with every permutation of a developing or evolving Earth. And so there are many features of us, many pieces of our evolutionary history that were essentially 5 Yahtzee dice on top of each other kind of events. They were events that only happened once in all of evolutionary history. They didn't happen twice. Abiogenesis itself happened only one time. The creation of the replicating cellular DNA molecule. Every organism on this planet is descendant to one Adam cell, or Eve cell. And there's no competing variety of life, even though there's body parts littering the surface of the earth, feet deep, full of amino acids and all kinds of DNA-friendly chemistry. No other zombie pops out to play the game. And the whole history of life on Earth, in those 4 billion years, there's no evidence of a competing gladiator. So it indicates that this isn't what the universe does. And the fact that this universe does it doesn't mean anything regarding any intelligent purpose or function. It just means that yes, chemistry can, when it's in the form of a DNA molecule, it can get really funky. And that's the key ingredient, right? Take DNA out of the universe, and you're not going to be so impressed about the function of the universe, because it's just a bunch of giant balls of crap smashing into each other.
The cause of that state of the universe is naturally the previous state, and the cause of that state is the previous state. So essentially, whatever we human beings do, whatever other animals do, can be mechanistically, completely causally explained by the evolving states of the universe that lead up to whatever action or thought it is. Otherwise, I mean, to posit otherwise would be to suggest that our actions and thoughts are taking place outside of the universe, and so that is an impossibility.
Yeah, that sounds absurd to suggest that it happens outside the universe.
Well, we don't know what's outside the universe, right? We don't know what caused the Big Bang, so the Big Bang may be the consolidation of some other thing that's going on. So who knows? But the point is there's no evidence that in any of this process there is any will to create, any desire to make, any necessity, no longing for the existence of. None of this fabulistic, wishful hope of purpose exists in its function. It doesn't do purpose on purpose. Value, again, I'll argue, the universe would be a void of valueless, meaningless mush if it wasn't for this accidental creation of an illusion of suffering, harm, sensation, desire that's created in brains. Without that mechanism, without that thing existing, the universe is irrelevant in every respect.
Because the universe is everything that exists anyway. So yeah, because if your thoughts and actions did not stem from the prior state of the universe, well, what would they come from?
Exactly. All right, so we have a kind of like a mechanistic explanation, but now let's turn to kind of like the biology, the the more organic explanation. So we
This is kind of a mess of words, right? Well, instead of the organic, let's go with the biological. Wait a minute, that's the same thing. So anyway, let's see where he goes with this.
we have thoughts, and they're basically the result of our brains. So in the sense of our brains, I think what we can do is describe our brains as amazing processors of information. And
Yeah, well, even that's kind of a funny thing to say, right? I mean, obviously, it's pretty miraculous. I mean, it has defeated the odds for us to be here and to have this kind of competency. But to say, in a way, look at how much we have all of this and what we do with it. I mean, American Idol. I mean, we are silly. We as a generic class of thing is insanely silly. So there's no real intelligence there. I mean, in the culture that's manifesting, that's rising to the top. Clearly, the mechanical mechanism, the evolution, the mandates of the circumstance seem to be percolating fat, stupid fat, to the surface, not something called metaphorically cream.
And we can use the analogy of a computer. A computer takes a lot of information, puts it together, and it problem solves. It reaches conclusions based on its programming.
Exactly, and the difference would be is that the difference between the sentient creature and the unsentient is one of them is running programs that don't change, that are genetically coded, and one of them is running programs that are reprogrammed by personal experience. That's why we have a sentient brain, is so it has a mechanism to reward the thinking, okay, that fits into this category that's from the situation called preferable behavior. Sometimes it's preferable behavior for you to, jump into a lion's mouth. That is, if your wife is behind you and she's pregnant, that would be preferable behavior. Normally, if you're just out by yourself and there's no pregnant wife to be eaten, then it would be preferable that you find some other strategy. And that's what we're programmed by, is this environmental circumstantial thing that allows each individual organism to create its own programming based on the circumstances. So yes, we still have a huge amount of biological programming in terms of our basic visceral desires, but how we convert that into output, that is, interaction with the world, is much more nuanced based on our life experience, what we learn, and how our desires are reorganized. So our ego and different things, we can now tie them to an idea of having integrity or honor or virtue, and we can see those as good things to have. We can understand what the definition of those things are, and we can modify our selfishness to conform to these other things, and we can feel good about being a good thing. That kind of thing. So again, another subject can go on forever, but there's no magic to it. It's still tool-equipped organisms battling to replicate their internal blueprint molecule. That's what's happening on Earth. consumption, reproduction, cannibalism most of the time, and through the process of desirous addiction.
And so I think our brain does the same thing, based on our, evolutionary genetics, on our heredity, our genetic coding. It basically,
See, this is sort of annoying in a way, right? I think it's important to understand what we were as animals, to understand the basic desires. But it's equally important to understand we invented the condom, that we that we in the last 10,000 years of human civilization, we have acquired new software that doesn't have anything to do with natural agenda in most respects. It's the periodic table is not something you have sex with. It's not something you eat. It's something you gain knowledge from, and that knowledge equips you to better interact with the world, to better understand how the world is functioning, and to better understand the moral landscape, as some famous author would say, which is a really good word to understand. You can understand the value landscape, the real value landscape, not just your what smells good landscape.
processes what the senses perceive, what even the cells perceive, and then makes determinations, makes conclusions, makes changes. How does that sound?
Yeah, it sounds.
Well, again, what the cells perceive, you're just making this a little bit wrong. I mean, my neurons don't know. The neuron I have in my head tied to an image of a butterfly, that neuron doesn't know it's tied to the image of a butterfly. It doesn't know it's butterflying. My sense organ cells on my skin do not know that they're tied to they're a neuron tied into a whole neural net. Each cell has no clue about any function or any purpose. It itself is a biological mechanism, a machine, and it just washes dishes. It just refrigerates food. It's just doing a mechanical thing. Okay, it's chemically reflexively reacting to the world it's in. I suppose it's important to understand that electricity now plays a part with neurons, where regular cells are mostly just dealing with chemistry and the minor amount of electricity that goes with molecular bonds and such. The change is that we went from having chemical reflexes that takes a little while for a chemical to move around, for its density to get high enough for something to happen. And so that was a big difference, a big change in evolutionary capacity, or the capacity of the mechanism it ran on this high speed rail, of electricity. High speed communication.
It's pretty accurate. And everything is so interconnected, and everything's so quick, the way that our bodies work.
Yeah, well, we're incredibly slow compared to the quickness of the universe. The speed of light is 165, 68, whatever, 1,000 miles a second. All right? I mean, the universe is moving at a frame rate so much faster than this consciousness thing is happening. So even though you think it's all going really quick, we're going incredibly slow based on how the chemistry is working, and more important, the atoms and the photons. They're way, way, way ahead of you. Okay? They're weeks and months and days and years ahead of you in terms of how fast they're moving and how many books they've read and all the rest of the crap that's going on down there. I mean that metaphorically. I just mean that there's a whole bunch of complexity in every split second of your existence. Is like 10,000 years of action took place on a molecular level. And that gives us, and again, the other thing is that there's so much of this stuff. There's no way to describe the density of even this body is essentially as big as the universe we can see outside the universe out there that we know of, with all of its complexity, with all of what we call it, the universe inside of me is even bigger than what we've identified as pieces in that big universe. And that's just talking in terms of the smallest thing being an asteroid or something. I mean, just accounting for all those little bits, you would have just as much trouble accounting for all the atomic bits inside of me right now. An apple is to the earth what an atom is to an apple. The density of this mechanism is incomprehensibly huge. It's a giant ocean, but what we can know about it is it's just basically salt water. It's 100 and plus elements interacting. It's big, but it's just doing simple.
That I don't think I don't think of the brain as some kind of a thing that processes information that's somehow separate from the rest of the body, because some people almost make it sound that way, and I get.
Well, neurology is it's made of sense organs, so I mean the very nature of it, and clearly there are organs that sense chemistry. So there's neural connections to the organ excretes a chemical, the chemical is refelt by the brain, in the sense that the brain now changes its function, the synapses get quicker, the things change because of the chemistry being flooded into the instrument. So yes, the chemistry and the neurology have a connection, but I don't think it would be fair to brain function to say that minor connection is the substance of brain function. It's mood is a really important part of what happens to our brain. It's important. Our glands are an important part of our neural function, but you could almost say that it would be pretty easy just to pop those back into our, put them back in the brain. And if evolution had more time, it probably would put your pancreas where it belongs, in your brain.
What they're doing is they're ignoring that all the sensations, every type of input, every type of consciousness, every feeling, smell, sight, hearing, smell, all of these things are inputs, which is much more complex than what a computer experience is,
Oh, so that's just kind of a silly thing to say, I think. Obviously, the two are not very comparable, and then one's good at some things and one's good at other things. Computers are not very good at creating the illusion of consciousness, but frankly, they kick ass at grabbing an image and storing it forever precisely and accurately. Our brain doesn't do that too well. It stores a pretty mushy representation of our life experience. Our memories are, pixelated and not very detailed. So, it's good to understand they're both machines. One is a dishwasher, one's a clothes dryer. They function differently, but mechanically they're very similar.
Because there's keystrokes and there's mouse clicks and mouse movement, events and stuff with computer. But what biological things experience, the sensory overload, the input coming from so many different ports, you might say, is way more than any computer built by humans could handle.
Well, that's just bullshit talk. Any computer could handle is just nonsense. Again, a computer can handle up close Google Earth. I mean, it can handle incredibly detailed, incredibly complex matrices of knowledge and information. Very complex algorithms it can run, very quickly, and so it's just kind of silly to say you're better than Google at doing some tasks, because you're not. You're really suck at some tasks.
Yeah, I completely agree. We've got the five senses. We have all these other kinds of like the sense of balance. I mean, there's various inputs coming from different organs. From and all right, so like basically what we're described.
Yeah, I think it would be good to augment. This is another piece of archaic language, this five sense things, where we're just describing the crudest part of the mechanism. And I think obviously one of the the first sixth sense you would argue exist is the sense of consciousness, or the fact that it is a feedback mechanism and that you're sensing your own model of reality. You're creating a model of reality, and so it's the projector sense or whatever. So we already have a sixth eye and a seventh and an eighth, and yeah, it's a little more complicated than um, earth, wind, and fire.
Thing though is like to put it in the context of free will, our brain, in as you're explaining, in cooperation with, in conjunction with the other organs of our body and perhaps other, aspects of reality outside of our body. And well, no, certainly like the environment. The environment is certainly an input that's being received by this.
Look, they're all input devices or output devices contained in a mechanism that can move in, like a tank. So the tank has radar and telescopes, and has different internal devices for sensing the environment. Communication with a sky plane that's getting aerial images and all that kind of stuff. So it has an eye in the sky even. So it's taking an input and then it's doing the output thing, which is shoot a load on that guy over there. And we're sort of doing that. I mean, in a biological sense, it is, yeah, we eat stuff, we shoot a load, and then, we go to do the replicating thing, in the sense that we need to go shoot a load, and sometimes it ends up creating a Luddite.
Senses. So like basically our brain processes this information and arrives at conclusions. And again, I think like one way we could understand this is like with computers, you have like the hardware engineers and the software engineers that basically through series of experiments of just trial and error, they basically come up with these machines and the software to run the machines that I think we have to like essentially define as intelligent behavior, intelligent actions.
So does that make any sense either? I mean, he talks about trial and error, so he gets the fact of it correct. I mean, that's what the biology does, trial and error. It disposes of 1,000,000 to create one survivor, one that will replicate to maturity. That's what nature does all the time. Trial and error. Make any kind of monstrosity and wind it up and throw it in the arena. What the hell? It doesn't cost nature anything to do that. And the byproduct is that over time, you will create more tools, and you will create more complexity, and you will create more efficiency in doing this grab it, eat it, fuck it thing.
And again, we use that same description of that kind of behavior to what our brains do. Essentially, our brains are constantly processing information and coming up with intelligent conclusions, intelligent answers to whatever needs to be described. Now,
Yeah, well, they're not coming up with intelligent answers. See, that's almost that's another way of saying it the wrong way, in a sense. Your brain, okay, through through the process of making it more and more functional. It's like our eye. The first eye was probably just light and dark. It was all blurry, and then it got finer and finer and finer through feedback. Our intelligence is doing the same thing through a feedback process of eliminating contradictions. Thunder is Thor. Thunder is air moving. We have two definitions of the reality, and we find out which one makes more sense evidentially, which one has more evidence. There's no Thor poo falling on us, so Thor sounds like a dumb idea. And so, yeah, we go with this moving air thing and, the movement of electricity. Um, so we come up with a refined understanding of what intelligent is. And intelligence is just accurate description of reality. So it's another word that needs better definition. Intelligence is made of accurate descriptions of reality. We acquire accurate descriptions of reality. And as we acquire more and more of these accurate descriptions of reality, they create a bunch of dots. And if you connect those dots, you will see images created. The dots have an implication because they'll reveals, as you get more and more of them to correct, more and more puzzle pieces in the puzzle, it becomes more and more obvious what the next piece will look like.
Now, Chandler, so the where we're at is so certainly we human beings, just like computers, do things, basically manifest processes that have to be termed intelligent. But the problem is that because we don't have a free will, this intelligence can't be fundamentally ascribed to us.
Yeah, well, whether who you subscribe it to doesn't matter. The real tricky part is recognizing that because it's in the form of nice, pretty words, and the sentence has a comma and a period in it, doesn't mean the sentence is intelligent. So the fact that we can talk and say things and put words together, that in and of itself is not intelligent if the words and things we're putting together is incoherent as a description of reality. If it's a lie, if it's nonsense, if it's absolute made-up rubbish. Bugs Bunny is not a real rabbit.
So, given that, how would you define or explain the intelligence that we manifest?
Well, it's interesting because it seems to be a universal intelligence, one that doesn't belong to anybody. It's sort of public domain.
Yes, accurate description of reality is public domain. Yes, and that's all our brain's basic function is to accurately understand an environment so it can navigate it coherently. So our basic brain function is logic. Our basic brain function is to get the image right, to resolve it to fine lines and detail, to put it in focus, to see it in focus. That's the basic function. Unfortunately, that basic function can be thwarted once you have false premises, delusions, put into the mapping of reality, because then you'll start bending everything else to fit those false puzzle pieces. You'll start cutting things off of other factual statements to make them fit your nonsense. That's not, strictly speaking, intelligent. That's a representation of the flaw in the universe, the chaos, the noise.
It's kind of, yeah, and you have to get back into, well, what is us? Because if we are a collection of cells, it's not like there's one cell or one single gene in a strand of DNA that is us. And so, I sort of get how the self is an illusion, And so this is weird. So I think of me as life. I think of you as life, almost like that we're.
See, these are the words that just don't go anywhere. Yes, of course we're life. Okay, we're biologically alive. We're a system of living cells made of living cells. But again, you have to understand the levels of complexity. We are as distinct from the paramecium, from the cells that make up our body. We are as distinct as a mechanism. The difference is the difference between a Lego and the plane it makes, an atom of steel or aluminum, and a wing on a plane. I mean, the difference is hugely distinct. there's nothing about the pieces that have much at all to do with what the thing is. Okay, you just don't call airplane, aluminum manifested in the purpose of flying. You just don't bother with that nonsense.
We're all part of the universe, and we're all life. So it's.
And well, again, and this, we said the illusion of self. You've sort of got it backwards. The illusion is consciousness. Self is not the illusion part. I mean, obviously, the idea of a personal feeling identity is part of the illusion of consciousness. But the fact that we are individual machines is undeniable. There's just no reason not to recognize our selfness in the sense that we are self-contained individual mechanisms, just as my cells are individual cells mechanically functioning in an environment. They're not friends with each other. They're not connected in some way. They're sometimes very hostile to each other. The cells in my body right now consuming each other. It's not a self is a reality. Individuality is a reality. The fact that I can see, form, recognize distinction between me and the air around me is a fact. It's a recognizable feature of this thing's existence, that it can be called an individual. It can be identified and recognized as an individual mechanical thing.
Sort of like we are all part of one universal life, one gigantic beehive or something like that.
Again, so now these words just don't mean anything. So now you don't even need a DNA molecule to be called a life. So, and there's absolutely no evidence that human beings are creating a machine that's going into the world and feeding and reproducing. There's just no evidence that we're mechanically doing the same things my cells have been enslaved to do. My cells have been enslaved by this packaging, by a DNA molecule that forces their enslavement to this machine. They've been forced, my liver cells have been forced to be liver cells, my kidneys have been forced to be kidney cells. It's all a forced march for all these pieces. And there's absolutely no evidence of any instrumentality forcing the human organism into an organization that will move through the universe and eat a good dinner and then have a romantic evening and all that. No, there's no evidence of any organs. There's no evidence of the penis island or testicle island. There's no evidence of functional organs in the diversity that exists among humans. There's no coherent function. It's a blob of goo at best. It isn't close to something you would call a life form. And that's just the humans. The rest of the universe is even less than a ball of glue.
Well, it's interesting you mentioned that, Chandler, because basically last night I was reviewing James Lovelock's theory of Gaia, where he I think proposed this back in the 60s, and at first it was ridiculed, and it basically describes the Earth as a self-regulating organism.
Everything is can be called a self-regulating. Now, organism is really stupid language, okay? Just as I was just trying to describe. Organs are usually necessary to the function of something bigger. You don't call a liver walking down the sidewalk,